Welcome to the C3S interview series. My name is Deepak Srinivasan. I am a research intern here at C3S, the Chennai Center for China Studies. Today, we're going to be discussing the topic, the impact of the China-US trade war on China's semiconductor industry with our distinguished guest, Mr. Arun Mamphazy. Thank you, sir, for joining us today.
Yeah, hi. Thank you, Deepak.
Yeah, it's nice to have you here, sir. So, a brief introduction about our guest. Mr. Arun Mampazhy graduated from IIT Madras with a B.Tech in in electrical engineering and completed his master's from the University of Maryland in USA. He specializes in microelectronics, especially semiconductor devices and integrated circuit fabrication. Mr. Arun has more than a decade of industrial experience, including being a member of technical staff at IBM India and a manager for multiple teams at GlobalFoundries-India. He has written multiple articles and appeared in various TV debates about his multi-decade-old dream of wanting to see semiconductor fabs, especially silicon-based high-volume fabs in India. Now, before we commence the interview, let me just outline the key theme that we'll be exploring. So, over the past several years, China has been viewing the semiconductor industry as an essential component of both its economic strength and its national security. Now, the PRC has been attempting to become self sufficient in this industry and has made a key goal in the Made in China 2025 plan. Semiconductors are extremely important because they serve dual purposes with both civilian and military applications, and they're essential in green technologies and electrical vehicles and artificial intelligence, which are all key sectors for China. They're also an important component in goods like telephones, computers, and broadcasting equipment, which are among China's top exports. Now, historically, China's policies for developing the chip industry have been unsuccessful. Despite pouring billions into the industry, China is several years behind the West in terms of semiconductor technology and relies heavily on other countries for semiconductor manufacturing equipment. China has pursued an aggressive campaign of trying to improve their technology by attracting foreign researchers and setting up the big fund to acquire foreign companies along the semiconductor supply chain. In 2018, the US launched a series of trade sanctions against China, alleging fraud, intellectual property theft, and selling dual use chips to countries like Iran and North Korea, which are enemies of the US. This kicked off the current trade war between the US and China, where most recently the Biden administration imposed export controls on China in late 2022. Right, sir. On that note, shall we begin the interview?
Sure. Thanks for the introduction.
Yes, sir. Okay. So the first question that we have. So recently, Chinese companies like YMCT made the new 3D NAND chip, and Huawei developed the new 9000S 5G chip, sir. So how have they been able to make these advancements despite the export controls?
So let me answer this in a couple of different parts. On the first part of my answer, one must distinguish between YMTC being an actual fab for memory chips. In this case, you spoke about NAND versus Huawei, which directly does not make any chips, does not fabricate any chips, but it being a the mobile maker as well as network gear maker, right? So in other words, one is a fab and the other is fabless. Now let's first look at the fabless part of the how Huawei might be able to make progress. First of all, China still has fabs, especially SMIC, which does chips in high volume, about 10 nanometers for sure. Below 10 nanometers, 7 nanometer chips, there has been reports of I'll just call it SMIC, SMIC, I just call it a SMIC. So there has been reports of SMIC being able to make 7 nanometer chips. Some of course said that they copied over or they got some technology help overtly or covertly from TSMC. And TSMC, while it did 7 nanometer, it did have two approaches. One approach is using or rather the first success of TSMC in 7 nanometer was using a slightly previous generation, what is currently a slightly previous generation lithography tool, which is based out of DUV, deep UV light of 193 nanometer wavelength, with immersion, with the numerical aperture being enhanced using immersion technique. So using that tool, directly you can't get the resolutions which are needed, or the smallest feature sizes which are typically needed for a 7 nanometer chip. The smallest feature sizes needed for 7 nanometer chip are not really 7 nanometers, but probably something in the 20s and the 30 nanometer range, for the first level of metal and so on and so forth, are the most crucial ones. So with the DUV immersion lithography, you can't get those resolutions, but using multiple patterning and a few other tricks, you can achieve the resolutions needed for 7 nanometer chip. To put it in a very simpler way, if you have to create a line or a trench or a little island which is X nanometer wide, you basically cut it into almost four different steps, each of which has a resolution four times needed than the smallest resolution. And then let us say you do a little bit of shifting in the photo mask that is used, and cut off the unnecessary pieces and basically achieve the smallest dimension that you need. So it's a very common man way of explaining a multi-patterning technique, but using such steps, you can do 7 nanometer. TSMC was successful in doing 7 nanometer using the DUV and the multiple patterning techniques. However, they are economically little less viable, because the yield percentages, you make 100 chips, how many of those work? That is their yield percentages. The yield percentages, ideally you need, I mean, in mature technology, you nodes, you need like 99 and 99% plus yield and so on. But for advanced technology nodes, at least 60-70% yield. Otherwise, you're going to run into losses. So with the multiple patterning techniques in DUV, the yields were not so great. And moreover, because you need more steps for the same level, you need where you could use only one photo mask for a level, and now you are ending up using four photo masks and associated costs, associated process costs, and things like that. So naturally, the cost was also high, the yield was also low. So this is where, when the extreme UV based 13.5 nanometer wavelength lithography tools were brought in by ASML. Initially, though, the cost of each machine appeared pretty high. Eventually, that cost was compensated because of the tool being able to give better performance in the fabrication of 7 nanometer chips. You could do where you needed four different steps to fabricate a level using the DUV tool. Here you could directly do it in one step, sometimes two steps. And so that naturally, and also with much better yield, so that naturally improved um, the economics of it also. So eventually TSMC moved more into the extreme UV based 7 nanometer, which it continued to use for 5 nanometer also. By the time it reached 5 nanometer, there was no more of DUV plus multi patterning being used by TSMC. And then now, of course, 3 nanometer also, they don't use any DUV. I mean, I'm talking about the most critical levels using DUV. DUV is used for the lesser, I mean, in every chip, you will have some layers which needs the smallest dimension, then there will be some layers which need the next dimension, and then the next, and so on and so forth, all the way up to even microns of micrometer levels of dimensions for you to make the final connection. I'm not talking about those later levels in a chip. I'm talking about the most critical levels in the chip. TSMC doesn't use DUV and multiple patterning anymore for those. They use EUV. Now, what the US restricted in terms of for China initially was the UV machines. because of even though ASML is a Dutch company, there are, I think US invoked some kind of rule that exists where it says that if a certain percentage of particular equipment has or if a particular equipment has above a certain percentage of US components or US contribution, then that particular country cannot export that without the permission of US, and US didn't give permission to the Netherlands to export it to China. Uh, but having restricted on the UV front, SMIC is said to have adopted the multiple patterning route DUV, because SMIC already has the DUV tools, immersion DUV tools, which were supplied probably in the early 2010s and all, when it would have come into use in 45 nanometer, 28 nanometer, and so on. So from that time onwards, we already had those tools. So using that and multiple patterning, they're supposed to have achieved the 7 nanometer. Now, what we don't know are how uh, uh, how much is the yield of these 7 nanometer chips that SMIC makes. Are they able to make economic sense out of it? So these are factors not known. And also, see, for a fab, for a what is called as a foundry model, your agreement with the company, let's say in this particular case, Huawei is trying to make certain 7 nanometer chips at SMIC. You can have two kinds of contracts. In one contract, Huawei can tell SMIC that we will pay you only for the working chips, right? Any chips which don't work are your headache, as in the foundry's headache, SMIC's loss. It's one way of contract. The other way of contract is where SMIC will, or SMIC will say that, look, you give us this much money, you need or in other words, the non-working chips are Huawei's headache, right? So where SMIC will say that you give us a design, we will fabricate 100 chips and give it to you for a certain cost. You go and figure out how many of them are working. Those which are not working, bad luck. You have to reorder and we will pay again the money, right? So we don't know which of these models are followed. Both are Chinese companies and both are kind of controlled by the government anyway. So who bore the bit of the economic loss for the sake of proving to the world that China can make 7 nanometer chips and Huawei can get 7 nanometer chips into the products. We don't know who took that, who absorbed that loss, if any. Now, having said that, we also don't know if through SMIC is the only way that Huawei is actually getting 7 nanometer chips, or by any chance do they have any backdoor arrangements with TSMC, or well, Intel is less likely, but with TSMC, or if they are repackaging any, let us say, slightly lesser node chip and sort of doing something and claiming that to be 7 nanometer. When it comes to China, you probably know better than I do that nothing can be trusted. So all of these are possibilities, and so the simple answer to the question as to how Huawei is able to get some of these chips into their system, despite the US export controls, is that there are two possibilities. Technologically, also it is possible using the DUV and multiple patterning methods and so on and so forth. We just don't know how much of economic loss they have in doing that. And secondly, through some clandestine means also is possible, which we don't know yet as to if they're doing or not, right? The second part of your question, in terms of how is YMTC able to do some of these things, again, the answer more or less is the same, that the kind of chips, that the 3D NAND chip that you're talking about, will need mostly only the DUV based lithography tools, and in other words, they should be able to make it with the existing tools that are available in China. Whether the YMTC itself had the uh, uh, tools from before or recently, because YMTC has gone through some cycles of almost completely bankrupt going bust, and then the government putting in some money back and reviving it and so on and so forth. So in all of these, who gave them the equipment, whether they really imported it at that time, and by the way, now the US policy, I have not looked at what exactly is the latest, but in between there keeps news keeps coming saying that now even DUV is being restricted, or the service for these already sold equipments are also being squeezed. The companies are being told that, look, don't go do service for these equipments, and so much of these. So I myself don't know exactly what is the situation now, but my guess is that China is still being able to buy the DUV machines, which they have two options. They can buy from ASML, which is still the leader, and I think which is the other one, Canon or Nikon. One of them also makes the DUV ones, right?
Yes.
So both these options are there. Um, yeah, I think Nikon makes the DUV ones, right? Yeah, Nikon makes DUV steppers. Um, so in that sense, technologically, it's still possible for YMTC also. The NAND chips fall under the bigger category of memory chips. Within memory, you have flash memory, NAND, so on and so forth. So there also, for companies like Samsung or SK Hynix, for some of the latest ones, which is kind of like a 10 nanometers, 12 nanometers. The technology, node coating a node for some of these memory chips is not as simple as coating it for the logic, but still around that is where you need EUV. So those things, as to the best of my knowledge, YMTC is not being able to do that. But some of these other 3D NAND solutions or chips they've been able to come up with, which again is technologically possible. Now, final word in this topic, and then I'll let you ask follow-up questions or next question. Overall, one of the things that US have to be careful is that they can only most likely slow down China's progress. I don't think they can completely stop China from. I mean, they can possibly keep China still a couple of generations behind them, maybe three or max, up to three or maybe even four, up to four generations behind. When US does 2 nanometer on its soil, China might still be at seven, or things like that. But this whole restrictions have also triggered a lot of efforts from China's side in terms of developing many of these things in house, right? Including developing their own EUV based lithography tools, or exploring other possibilities of lithography and things like that. Uh, so we don't know yet as to where they're headed. Uh, and whether one or two breakthroughs that they might be able to achieve, and they might actually be able to challenge US even on the latest generations.
All right, sir. Thank you. That was very thorough answer, sir. I don't think I have any follow-ups for that. So I'll move on to the next question, sir. So, like I said, China is focusing on the semiconductors. One of the reasons being that it's also a key component in industries like artificial intelligence and electronic vehicles. So, how do you think that these sanctions or these export controls are likely to affect those industries, not directly just semiconductor firms, but firms which are involved in artificial intelligence or green technologies or electric vehicles? How will controls affect those companies in China?
My short answer would be that the restrictions on semiconductor uh, chip making related areas alone is not going to challenge China in its progress on AI or any of the other fields wherever it is making. I'll explain it in a couple of different ways. The point is that a lot of these emerging technologies like electric vehicles and many of the things, China will be able to make huge progress on that based on non-advanced chips, mature node chips, Power semiconductors, for example, power chips, for example, do not need or cannot use the most advanced technology node. They have to be in mature technology nodes in order to be able to handle high power. Likewise, non-silicon based technologies like gallium nitride and silicon carbide and so on, even though they are not universally used for the purposes that silicon is used for, the gallium nitride, silicon carbide, and other compound semiconductor fabs are used for specific areas, especially high power related areas, and a little bit in high quality or high performance communication and so on. So those areas also US will not be able to restrict China, because the so-called technology node concept is completely different there. You don't need EUVs and things like that. In fact, you are talking about 100, 3-digit nanometer technology nodes, or even sometimes half a micron, 1 micron kind of technology nodes, if at all, if you're talking about nodes for them. So there, and in fact, some of the basic fundamental materials that are needed also, China might be good there as a matter of supply chain and things like that. So it's very tough there for US to restrict them in any of that. In terms of artificial intelligence, or let's say high performance computing, cloud and things like that, there, yes, to certain extent China will suffer because of the lack of the sub 10 nanometer chips, 7 nanometer, 5 nanometer, 3 nanometer and things like that. But again, whether they will do it the hard way of throwing more money at it and using multi-patterning and things like that and come up with these chips, or the alternate way in front of China is that, look, I mean, you don't necessarily need all 7 nanometer, 5 nanometer chips. If you're able to get 10 or 12 nanometer chips, or which MIC will be capable of doing, or even 14, 16-ish range, you can use many of them and achieve the same kind of AI power, or other cloud computing power and things like that, as you would need. I mean, you can get with the advanced node chips. The numbers you may need more numbers, but there are always other techniques that you can use to parallel process and multi-threading and so on, so many other things. And even in this fabrication world, this whole concept of wafer size chips that are emerging, Cerebras and then Tesla's, I think its name is Dojo or something like that. Those guys are what they are trying to do, where in a big 300 millimeter diameter wafer, where normally you make 100 or 200 same chips of multiple iterations of the same chip, and cut them all into individual chips which are supposed to function similarly. Instead of that, where you make one whole wafer full of chips where they're all interconnected, they might be similar functioning chips, but you don't cut them out, you keep them all connected in order for you to give this high performance. So these things can be also tried in 12 nanometer, or 16 nanometer, or even 28 nanometer for that matter. In other words, if you make a wafer sized 28 nanometer chip, I mean, theoretically, I'm just saying, you might still be able to get the performance of one wafer with, let's say, 100 of these 28 nanometer chips connected to each other, might still give you the kind of performance that handful of 3 nanometer separate chips can give you. And on top of all of that, because these things are spread out and they are handling 28 nanometers, your ability to handle the heat generated out of that operations, and the thermal conductivity and heat sink and things like that, these things can be better off actually in a wafer sized one, because the other one, the individual 2 nanometer, 3 nanometer chip will have a smaller chip area, and then you're handling much higher power, whereas the other one, 28 nanometer, will be able to handle that power. So even there, with a certain amount of workarounds, China might be able to, in terms of at least computational power, give tough competition for the US. Where China may suffer or face a challenge, in my opinion, is still some of those conventional things, like, for example, how good are they with English? or how good are they with understanding uh, the whole world, right? Because China as a country is suspected to be a little bit more isolated or cut off in terms of their cooperation with the rest of the world and their understanding with the rest of the world and so on and so forth. And in a domain like artificial intelligence, those things might matter. For example, an Indian AI kind of company. I'm not necessarily talking about the hardware for AI, but if you have software-ish or software support-ish kind of companies for AI and things like that, an Indian company might be much better placed to support a Europe or a US as compared to a Chinese company, and these things can eventually have a trickle down effect on their ability to utilize their AI semiconductor chips and so on and so forth. um, to put it in another way, many times some of these AI chips will have specific requirements on the from the final use, where how are they going to finally be used, that is translated into better designs at the chip level itself, so that to give a very simple example, your central processing unit and your graphic processing unit are at the very fundamental idea level, they are the same, right? They are both processing units. However, you have certain things which makes the GPUs better, or in other words, if for a GPU as compared to a CPU, you need to emphasize on certain things better, certain things have to perform better, and so on and so forth. And that is why your CPU GPUs are different from CPUs, and these days you have many more PUs. Almost every alphabet in the English alphabet is being prefixed instead of in front of a PU to call it whatever, whatever kind of processing unit it is. So in those things you need a bit of an understanding of other languages and other countries and the requirements and so on and so forth. There it might suffer. In other words, from a global market perspective, China might suffer a bit, which you can also see that impact in terms of China's fabless companies. So I'll just bring up that point. I'll connect. It's a slightly different point, but I'll connect it to this. In spite of all of this, if you look at the fabless companies, global fabless companies in the world, look, I mean, China, as of now, as per American studies, China has about they say almost 20% of the global semiconductor fab capacity. Whether it's 20% in terms of volume or whether it's 20% in terms of revenue, I'm not too sure, but 20% is what the Americans claim that China has in terms of global fabrication capacity. It can be Chinese companies, it can also be American companies like Intel, who has a fab in China, but on Chinese soil, 20% of the world's chip fabrication happens, is what the Americans claim. But despite that, they don't have that kind of a hold on the fabless global market share. The fabless is still dominated by America, the Qualcomm and the Nvidia and the all of that. And Chinese have not been able to make that kind of a headway with their guys, right? Except in their own local market, they may be, but not much in the global market. So this is the kind of situation that I'm talking about, where uh, going back to your question in terms of in all these emerging areas like AI and EVs and things like that, I don't see the US restrictions causing that much of a problem for China, or that much of a downfall for China because of that. There could be other reasons why China might not dominate in some areas like AI, but in areas like EVs and things like that, they're already on its path, and it's very likely to, we are very, very likely to see them keep going up despite any kind of, at least not the kind of sanctions that the US have given so far to China.
All right, sir. That was very succinct answer. following up on that, so in this answer and in the previous answer itself, you talked a lot about the costs involved with this and how these costs have sort of shot up after the export controls were launched and things like that. So China recently launched the new phase of their National Integrated Circuit Investment Fund, or their big fund, and this new phase has around 47 billion US dollars into it, which is the largest of any of the phases so far. So, what key areas do you think this new fund should focus on from the perspective of the Chinese government?
Yeah, again, many times they keep a lot of things under wraps. But my suspicion would be that a lot of that might be earmarked, or the push might be for equipment manufacturing, the tools that are needed in the fab, right? For example, the lithography, stepper scanners, things like that, which eventually ties into China's ability to do in-house advanced node chip manufacturing also. The second area which we will, so, as I said, out of the 47.5 billion, I would tend to think, or if I were China, then I would possibly look at the first priority being some of these equipment manufacturing, because the latest ones they don't have, and they are not being able to get. And even the existing ones, the conventional, or slightly behind generation ones also, you never know when they will also get switched off, or services will stop, and without annual preventive maintenance and all, it becomes very tough to maintain these machines, or if they go bad, then to get them repaired, and so on and so forth. So that would be the first priority. The second priority that I will look at will be in some of these specialized areas, like the electric vehicle segment, and things like that, where again, the as of now, there is hardly anything which can restrict China's progress in that. And if you look at some of the charts that came out a few years back on what are the new fabs that China building right now, you will see a lot of compound semiconductor based fabs also in them, which essentially caters to these EV kind of segments and things like that. So that I would think will be their second kind of high priority. The third area that I would watch out for is the fabless that I just mentioned, as to how much is China interested in all of these manufacturing that they are doing. They continue to be partly for China's domestic use and partly for the world. I mean, there is, for example, even now, for all the mobile assembly that happens in India, India is supposed to be importing around 26 billion worth, or so worth of chips. And there is the CHIMS, I think, right, website, chip import system of India, where all the folks who are importing ICs or semiconductor components in India have to register on their website, and I think then the import duty is free or something like that. So if you pull out reports out of that, I was not able to, but if you're able to get somebody who can pull reports out of it, you will see a lot of those chips come from China. I mean, it might say Hong Kong because the final the person who wraps the box might be a company based out of Hong Kong, but they are all essentially Chinese chips. I mean, I'm not talking about like Apple. If an Apple mobile is being assembled, the main processor chip, of course, is made in TSMC. That's not a China made chip, but rest of the smaller chips and other mobiles that are getting assembled in India and all, we don't know where these chips are. Many of them might be Chinese. So so that part continues to happen. For China continues to be a supplier of not the most advanced, but the lesser advanced node chips for the world, though different countries might be buying them in different quantities and things like that. But the fabless part, which I just mentioned, like Huawei, by the way, Huawei also has this arm called High Silicon, right? Which many times it's not Huawei who's directly acts as a fabless. It's high silicon which acts as a fabless. I mean, the equivalent of a Qualcomm or Nvidia and things like that. But anyway, these guys so far are known to focus. Well, when I say so far, I would say probably since 2018 or since 2014 or things like that, they are they are known more to use most of it for domestic use only. Before that, many of these network equipments that are there, I mean, even now, for all we know, had Huawei based chips and things like that. But then eventually, at some point, the US banned any of those network gears which have, from Huawei, and then India also kind of stopped and all. Uh, we now use Nokia, I mean, all these Ericsson and all, but we don't know whether they also eventually have a backdoor deal with China and all. We don't know. But the point is that at least in the public domain, or at least in the known case, the Chinese fabless predominantly cater to their domestic needs. Now, whether this part of this 47.5 billion fund will also be used in order to make them more global and catch. If I remember it right, out of the top 10 fabulous companies, there was only the 10th one or something was Chinese. So now whether to prop it up into a better rank and get more Chinese companies inside the top 10. So that could be the third priority that China has. And the final point, of course, is a SMIC or moving into the actual 3 nanometers and things like that. Either using, um, if the equipment manufacturing in China picks up, and if somebody is able to make those EUV kind of equipment in China, then that becomes the uh, if, facilitator for those advanced node chips. But in the absence of that, as I said, I mean, 7 nanometer itself will be more costly using multi-patterning. There are recent news about few weeks back. There were rumors of China being already made a 5 nanometer chip also using multi-patterning, but I know not confirmed yet. Those will even be more costly, or in other words, all these yield loss and things like that, who's going to bear it? Whether some part of the fund from this 47.5 will be used for that also, we don't know yet. So these four, I would think, are the first that comes to my mind. As in, first equipments, second some of these compound semiconductor sort of things, and third fabless, to take their fabless much more global, and fourth and the final, the most advanced nodes, SMIC achieving the most advanced nodes, or for that matter, not just SMIC, or and then YMTC in the memory domain, SMIC in the logic domain. Of that matter, they may have a plan for another fab which can be like similar to SMIC and all, right? Because right now, one challenge with China is that all they put all the or most of their eggs in the single basket of SMIC when it comes to logic chips. So whether they want to diversify that and prop up another fab focused on the advanced nodes, for example, like what Japan is doing for 2 nanometer, right? So Rapidus, something like that. China wants to do in China also. We don't know, but it's not that easy. It needs a partner and all, but we'll see. So I hope I've have answered that
Yeah,
for.
sir. Just a small follow-up, sir. So we've talked a lot about how these there's a huge cost involved with manufacturing these pumps, since the restriction of DUV equipment, since the restriction of EUV equipment to China, and how they've had to make do with DUV equipment. So because of this increase in cost, it would really drive down these companies' profits, and it would sort of reduce the amount that they have for further research. So, in terms of the long-term research of these companies, do you think that the government has enough funds to sustain them for a while, or do these companies in themselves have enough reserve funds to sustain them for a long time, or will this be something that will run out very quickly?
Uh, I'll just give you one data point. Until last year, SMIC was at best. I mean, I'm talking about the something like, let's say, for the last 10 years, SMIC was at best fourth. in terms of the foundry revenue. Foundry is only the contract chip manufacturing. I'm not counting Intel or ST microelectronics kind of companies which does both design and fabrication. I'm talking purely about the third party contract chip manufacturing. Are you there?
Yes, sir, I'm still here, sir.
Yeah, just wanted to make sure. Yeah, so TSMC, Samsung being second, and third used to keep oscillate between Taiwan's UMC and US headquartered GlobalFoundries. But this quarter, first quarter of 2024, SMIC has become the third. um, so now we don't know yet as to, so how are they managing it, in the sense that definitely revenue wise, and by the way, this is third in terms of revenue, I'm not talking about profit margin, just third in terms of revenue. So revenue wise, they are most likely able to get a better revenue because of their mature node chips, and they still do 14, 16, or maybe even up to 12, I don't know, but 20s and 28s and things like that, and they must be using it a lot for their domestic purposes and a little bit for outside also, right? So it's not really surprising that they're able to increase their revenue. What is not known is that are they using this part of this money for their research for advanced nodes and 3 nanometers and 5 nanometers and things like that, or are they using the Chinese government money, and if so, how much and how far and things like that? So that those things are not clear. Now, how long will China continue to do this strategy of throwing money at the problem? Again, we have no clue. They have their own mind. I mean, for a country like India, we would not have been able to do this. It's also a democracy. We have to consider that. China, for example, in the big fund that you spoke about, the previous allocation, some of them have gone essentially kind of, I mean, effectively partly useless. I mean, the example being YMTC, right? These guys were given a lot of money. There were probably even some scams associated with it, where the company executives made the government believe that they can deliver this and that, and eventually they did not, and the money went waste, or the money went into various pockets, which in the case of China, because the government is such, they may have recovered it. We don't know all those stories, but point is that at least to the outside world, you can see a lot of articles with for example, you started off by saying that the made in China goal, the goal really was, I think they said it in 2016 or 2018, and the goal was that by 2025 they wanted 70% self-sufficiency in semiconductor manufacturing, right? I mean, 70% of their domestic need should be made in China itself. And by around 2021, 2022, there were a lot of articles, including some in Global Times, which is a Chinese funded medium, which says that has China really achieved, or they're far behind the 70% target, and a lot of those articles. Um, and such a thing would have been, would have caused a huge outcry in a country like India, and which is probably why the government of India does not still define what are their percentage goals in terms of the global market share. For example, for the Tata Electronics fab that has been approved in Dholera. So, but how long will China be okay with it being kind of mocked by the world that you guys didn't achieve the target, or being, quote unquote, in the eyes of the world, losing money, being the money being thrown at the attempt of making or catching up with US? We don't know yet what will be their mode. But clearly, I mean, if see, despite I started off with one data point of SMIC becoming third. I'll give you the other data point of, if the Semiconductor Industry Association of America brings out an annual, or maybe once in 2 years, or annual, but their report, the data used might be 1 or 2 years behind data, but it brings out this report called State of the Industry, Semiconductor State of the Industry report. So if you look at something like a 2018 or 2019 report, the percentage of wafer fabrication capacity that China had was something like 16%. Taiwan was the first with 21% or something. China was 16%. In 2020, the 2022 or so report, which uses the 2021 data maybe, they report the China capacity as 20% or something, and even overtaken Taiwan. Now, there could be, it's two things are possible. One, either the Americans are exaggerating China's numbers in order to scare the American lawmakers who can eventually fund the Chips Act and things like that. So, because Semiconductor Industry Association of America are essentially, they are the beneficiaries, right? Because American government will give them funds, and the SIA kind of people will benefit. Or there is some truth in it. So it's interesting that despite all of these restrictions and despite China still not making almost the three generations of advanced nodes, 3 nanometer, 5 nanometer, 7 nanometer, probably even 10 nanometer, though overall in the world 10 nanometer is hardly not much made anyway. But still, at least three generations China is not making in a huge volume. 7 nanometer they're making, but maybe not in a huge volume. Despite this, the overall capacity of China is growing up. Is something that is a matter of curiosity, right? So to circle back into your question, um, we don't know yet if China is actually suffering with all the money being quote unquote lost, or they are not too bad after all, because some of these numbers like SMIC becoming third and China's actual wafer fab capacity going up actually shows that China is making progress than going in a negative direction. And secondly, even if it is hurting them a little bit, how much of importance they are giving to this compared to their national security, or the sheer desire to see them take on America in this field, or in general take on the rest of the world in this field, we don't know yet, and probably only time can give us the answers on this. Or to put it in short, where is this rat race going to end? We don't know yet.
All right. All right, sir. Thank you. Now we're going to sort of shift to the US perspective. So, how do you think US technology firms are being affected by these export controls and these sanctions?
It's a bit of a tricky question. I see US had a similar situation in the late 80s when Japan came up as a major competitor to its semiconductor industries and things like that. The approach that they took at that time, at least to the best of my knowledge, it was way different. They came up with a Sematech idea. There was a consortium formed of all the US industries, and uh, DARPA funded consortium and Sematech, and then they the in my understanding of the whole way it was handled, the emphasis was much more on let's do better than Japan. Let's if they are doing good in technology, let us do even the better technology. Now and by the way, that led to a lot of very very good initiatives. Sematech, I mean, was one of the spin-offs of that effort is this um, sort of an intermediate research organization in the SUNY campus, which is where still IBM still has a lot of stake there, and some of uh, the very basic stage of some of the technologies, including 5 nanometer, the gate all around technology, for example, which Samsung has already moved into it for 3 nanometer. The rest of them will move into it for the 2 nanometer. So these things, a lot of them are still being developed in those places. In other words, innovation, the approach at that time was let's innovate even better and counter Japan. Whereas now, I mean, it seems like a slightly different approach, and somewhere down the line, I kind of get a feeling that it is going to come back and hurt US itself. It has already started hurting in some ways. One way, of course, is China becoming even more aggressive in its effort to make more and more things local and more self-sufficiency, including equipment manufacturing and things like that. Second hurt for the US is the fact that many of its own companies are losing market, right? I mean, its companies, as in companies with the US headquarters, they are losing market because they are being restricted in selling chips to their chips to Huawei or any of that. So naturally, it's putting the American-based companies under stress. China is a huge market. There is no denying that fact, and uh, whether there were lessons to be learned from the way US handled the Japan competition in the late 80s, early 90s, or whether China is a completely different matter. I don't know. I'm not a geopolitical expert on this, but maybe there could be reasons because the Chinese challenge is much more about labor. I mean, manufacturing, especially labor intensive manufacturing and things like that. Whereas the Japan challenge that came up in the late 80s and 90s were a bit more on the technology side. Um, so maybe that is the reason why US is taking a different route where it knows that US cannot counter China in terms of the labor effectiveness or the labor force that is available in China, or some of the cost effectiveness that China can bring in terms of constructions and this and that, right? So it cannot counter China in that front. So maybe it is countering China in terms of market and restrictions and things like that. So that is probably the reason why US has taken this path. Whether it is long term sustainable, whether US is doing the right thing or not, I don't know. It's too complex a thing to make a judgment. Again, time will tell, and the whole thing can collapse. All the US effort can collapse if China is able to, as I said before, China is able to make a few breakthroughs like local lithography equipment manufacturing, or like some other technological breakthroughs that they might be successful about. So if they don't make any of those breakthroughs, yeah, maybe US can continue to squeeze them, continue to delay their progress and restrict their progress, but partly also impacting its own companies and things like that.
Yes, sir. Moving on to the next question. So, it's not just that the US is imposing export controls right now. The US is trying to get other countries to also launch export controls on China. So, as you mentioned earlier, they tried to get Netherlands to restrict DUV technology and EUV technology, and they currently have this proposed chip 4 alliance between the US, Taiwan, Japan, and South Korea in order to further try to isolate China. So, do you think it is likely that countries apart from the US will impose further restrictions on China, and what level of restrictions do you think they'll impose?
Yeah, I think the short answer to that question will be it will depend on what each country, what kind of relationship each country will has with the US and with China. In other words, there is probably no single template to answer that question. For example, even out of the chips, chip for alliance, South Korea is not that cooperative as Taiwan or Japan. Each one has their reasons to either support, or to the extent of support given to what the US is asking them to do will vary depending on how much they need US and how much they need China. In the case of Taiwan, it's quite clear, right? It's their security and protection and so on and so forth from China. So most likely Taiwan is a more or less a fully cooperative country in terms of US. With of course the catch that it is very difficult to cut off the Taiwan China, that umbilical cord sort of a thing, where a lot of for example, Foxconn is a Taiwanese company, but its most number of factories and its most number of workers are in China. And you can't simply tell them that pull completely out of China. Where are they going to go? They can slowly move some of them into India and things like that, but it's not a black and white answer. When it comes to Japan, it's a little bit of a different story. They do have their own little grudge against China to grind also, and except for some equipment manufacturers and chemicals and things like that, their fabs themselves are not majorly China is not a major consumer of some of their, their fabs per se. But however, going forward, when some of their most recent efforts, like there's this JSM, Japan Advanced Semiconductor Manufacturing facility that Japan, Sony, and what is the other one? Three of them are doing together. That, and then Rapidus 2 nanometer fab that they are trying. Once these things start coming up and they actually make high volumes of chips, then how much they can ignore China as a market is to be seen. And at that time, what is going to be their attitude to the US restrictions on selling any chips to China is something that will have to be seen at that time. Right now, Japan is not losing much by restricting selling to China, except for some of these equipments and chemicals and things like that, which maybe US is not fully restricted yet. South Korea is a different story, because definitely their biggest product is memory chips, and China is a big market for memory chips. And Samsung and SK Hynix they do have fabs in China. And by the way, those guys were given an exception to import some of the equipment to China. So the Samsung and SK Hynix facilities which are there in China can import certain equipments which are otherwise not allowed for other Chinese fabs and things like that. But for importing them, they need permission, right? That's the situation. So South Korea is not too happy with the US. So they sometimes attend that meeting. Sometimes, they're not too happy, or they're not fully on board. But it's a love hate relationship that's going on. So the other countries also, for example, the European countries and all, if they don't have much to lose by listening to America, they will probably tag along. But if they don't, then it will be a tricky situation where temporarily they may nod their head, but they'll do a tightrope walk. That's all. But yeah, I think that's more or less that is my answer. If you have any specific countries other than what I just said, you can let me know.
Yeah, okay. Thank you, sir. Moving on to our final sort of concluding question. So we've talked a lot about how China is sort of isolated from the rest of the world, and even if it sort of manages to make some sort of technological advancements, it's at a huge cost, and it's not really up to the global standards. So even if China is somehow able to make the technological advancements that are required for it to be somewhat self-sufficient, do you think that it will sort of be able to compete in the global market? Will it be able to meet global standards anytime soon?
Is that, just a clarification, is that related to the restrictions, or is it a general question as to how good is China in terms of its quality when it comes to some of these things?
It's a general question, sir, but it's supposed to be in line with some of the recent technological progress that China has made.
Okay. Again, so I'll maybe answer it in sort of two different ways, right? So the first is that just like some, let's say, the toys that were available in India and so on, or even many smaller things which are available in Indian market, the Chinese are good at flooding the market with chips, which are not talking about the most advanced chips or the most complex chips, but smaller chips, microcontroller units, chips that can go into your washing machines, or into your automobile for, let's say, sensing and things like that. So a lot of these continue to be Chinese made. Many times when you don't necessarily notice how, or if your reliability is not so critical, many times there is a general tendency in the market to prefer things which are cheaper, and China continues to win there. Now, the second part of my answer, I'll put it in two different ways. Assuming that there were no restriction, and a company or a fab like SMIC were actually able to get UV equipments and actually able to develop 5 nanometer or 7 nanometer, 5 nanometer chips without any kind of restriction from the US. In such a scenario, would a company like Apple even consider making those chips in China? No, because of yield issues, and much more important, because of IP theft and a lot of other uh, risk involved with getting them done in China. China can introduce hardware bugs into their chips. I mean, iPhone prides itself in being a secure or more secure phone than many of its competitors and things like that. In such scenario, letting the Chinese play around with their designs and introducing bugs into it, hardware bugs into it, is the last thing that an Apple would want. Likewise, their entire IP, as in the design and the design ideas and all, could be stolen by the Chinese and then given to its own mobile makers and things like that, which eventually, and you don't even have easy legal ways to prevent it. uh, so no way an Apple would want to fabricate in China. One of the reasons why TSMC is still one of the most reputed companies is because they protect the IPs given, the designs that are given by its customers to TSMC in order to fabricate them are extremely well protected. Their clients don't have to have any tension that some of their designs and design ideas and things like that will get leaked. Not going to happen from TSMC. So such a thing will never happen with SMIC, or nobody is going to trust SMIC. So the only or one of the predominant reasons why SMIC made chips are still earning money, earning revenues, is because a lot of areas they don't care about security that much. You're looking more in terms of cost saving and things like that. Now, with that said, now you add to it the US restrictions that are being placed. So it is going to become uh, more difficult for the China made chips to become a globally reputed standard. So I don't think that, especially in complex chips and the most advanced chips and things like that, I don't see anywhere in the near future where China becomes a competitor in terms of quality of its products, both from the point of view of traditionally they have not been, and from the point of view of the added restrictions that are in place. But they will continue to excel in terms of cost effectiveness and uh, flooding the market with cheap, quote unquote, cheaper chips. In fact, there are even cases of, let us say, some company like ST Microelectronics, which does microcontrollers for some of these, like, washing machines or some of those things that I spoke about, right? I mean, you can CH32, whole bunch of such things are available in the market. There were even rumors at one point that Chinese foundries are making their counterfeits, right? uh, Very similar chips being fabricated in China with I don't know what label they put. Maybe they put the label of the parent company itself, and they flood the market with them, that the consumers cannot distinguish between which one is really made by ST Microelectronics versus which one is made in China by a uh, whatever counterfeit company. I mean, I don't know whether ST Microelectronics had this counterfeit issue or not, but some of them had. In these things are chips which are, as I said, many times where people fall for the immediate gain of some cost saving compared to reliability. I mean, if as Indians, would we stop buying a washing machine if somebody tells us, "Hey, buddy, this washing machine has a Chinese chip in it, and because of that, it is 5,000 rupees cheaper compared to the other one has a Germany Bosch made chip in it, and it's that 5,000 rupee extra." Half of most of the Indians will go for the, it's okay, right? I'll 5,000, I'll save right now the 5,000. So let me go with the, doesn't matter the Chinese chip one, let me go with that. and no harm in it also. I mean, if you're lucky, it survives. If you're not lucky, you have to replace it, and replacing that chip might still cost you only, either it'll wipe out that 5,000 gain that you had, or you might still be able to change it once or twice with 2,000 rupee each, and you still save on the money part, right? So that is where the Chinese companies have traditionally made their money, and they will most likely continue to make their money on that way. Where reliability, more than reliability, is a cost effectiveness that matters. Plus, in certain areas where there might not be too much of a competition, or for example, in the electric vehicle segments and things like that. Right now, if you look at the solar starting wafers, right, some of these things China has a near monopoly. I would not say complete monopoly, but because they've done it so cheap, they've been able to make those things so cheap that even an Adani trying to make those solar starting wafers in India, I don't know how much of how much he can compete with the Chinese. Maybe he can be satisfied with the fact that from end to end it's being made in India. The wafer is also made, and the module is also made, and the solar cell is also made, and the whole panel is also made in India. From that point of view, it will help. But competing with China, capturing the global market in the solar wafer or solar cell or solar panel, almost any of that are tough. And that is where its reliability is not that critical. I mean, or efficiency, right? Your solar cell is 25% efficient in converting the solar energy versus the 20% that the Chinese offer. But they are offering it at half the price. It's okay, right? I'm losing 5% energy, but I'm saving almost half the price. So, in my opinion, that is where the Chinese are still going to excel. Uh, to put it in short, in terms of the quality, Chinese products, Chinese chips, Chinese or fabless products, or Chinese fabs products, neither of them competing in the global world in terms of the quality. I don't see that in the near future. But cost effectiveness, and thereby continuing to capture the market, that is most likely going to continue to happen despite the restrictions.
Okay. All right, sir. Thank you for this interview. So, some concluding remarks throughout this interview. We've analyzed China's semiconductor industry and the impact of the U.S. sanctions and some sanctions by other countries as well. We've analyzed the issue from a technological perspective, an economic perspective, a geopolitical perspective. We've covered some key points like how China is managing to make do with older technology, even though it has a high cost, and it's able to, the government is sort of willing to subsidize this cost for the foreseeable future in order to make sure that their sectors are very strong. And it doesn't look like the US is about to relax these restrictions either. And, in terms of, China's competence in the world market and the domestic market, its domestic market technology seems to be somewhat improving. Its quality in the world market is still a doubt, but it will always have that cost advantage, which makes it, somewhat attractive to buyers in the world market. Do you have any concluding remarks, sir?
No, I think you've summarized it pretty good. And thank you for the questions, and hope I was able to be of some use.
Thank you so much for your time, sir.